Hi everyone, in this video we're going to be working through an exam question involving finding the equation of the regression line, as well as finding Pearson's product moment correlation coefficient, and we'll also be seeing how to actually use the regression line we find, and we'll finish by briefly talking about extrapolation and interpolation. And one more thing before we start, the calculator I'll be using here is the TI-Nspire CX. But regardless of the calculator you use, the method and approach towards solving these questions will be similar. So let's get started. Here we're told, data collected from running on the treadmill is shown below. And we have our table here in which the first column shows the speed in kilometers per hour, and the second column shows the corresponding heart rate in beats per minute. Following that, we need to answer 4 questions. And so if you feel up for it, go ahead and press pause and try working through these questions before watching the rest of the video. And whether you did so or not, I'll get started. So the first thing I'll do here is I'll shrink this question so I have a bit more space to write some working and the answers. There we go. And you can now see my calculator on the screen. Now the first question here, question 1, we're told find the equation of the regression line for heart rate, that's capital H, against speed, lowercase s. Okay, so hopefully that's quite clear. We need to find the equation of the regression line. Well, to do that with our TI-Nspire, as you can see, I'm on the home screen page here. And so if you're not on this page by default, go ahead and click on the home button, which is the on button on your calculator. Once you're there, we're going to create a new document. And to do that, we can either use the right-hand column here and click on New, and alternatively, since what we're about to do is create a spreadsheet, we could also click on the spreadsheet icon that you see right at the bottom of the calculator screen here. But I'll go ahead and click on New. Then to create a spreadsheet, I select the 4th option, Add Lists and Spreadsheet, so I click on that. And now my first job is to enter all of the data that we have in our table here onto my calculator. And so let's see, the first column is speed, and so I make sure to name that column at the very top. That's in this cell here. And so that's speed, so I'll just write S for speed. There we go. The second column is for heart rate, which I'll just say is H. There we go. And you'll see why that's important shortly. Next, I enter the data. So the speeds go 6, 7, 8, 9, 10. So that's quite easy. I'll quickly type that. That's 6, 7, 8, 9, and 10. Okay, that's the first column taken care of. In the next column, the heart rates are 101, 109, 123. So let me quickly type that. That's 101, 109, and 123. And the last 2 heart rates here are 129 and 142. So I'll quickly type those. That's 129, 129 and 142. Done. Okay, all of that data is now in my calculator. I quickly double check that everything's typed correctly. So let's double check that. 101, 109, 123, 129, 142. And the speeds on the first column, 6, 7, 8, 9, 10. Everything looks good to me. Okay, so now that we've entered our data on our calculator, to find the equation of the regression line for heart rate H against speed S, here's what we need to do. I'll place myself in the first cell in the next column here, so right here. And on this calculator, to obtain the regression line, I'll go ahead and click on Menu, followed by the 4th option, Statistics, followed by the first option, Stat Calculations, followed by the 3rd option, Linear Regression, and in parentheses it says mx plus b. And so I click on that. Next, I can see that I need to specify which column corresponds to the x variable, or the x list. Now, what this calculator is calling the x list is the independent variable. And so here, since we're being asked to find the regression line for heart rate against speed, this tells us that the line that we're after should look something like this. H equals to some gradient, so some number, which I'll call m, times the speed plus some constant b. And so if you're comfortable with line equations, what you should be comparing that to is y equals to mx plus b. And what this tells us is that we're treating the speed as our independent variable and h as the dependent variable. In other words, the quantity whose value we'll be able to predict thanks to this regression lines equation. So, long story short, the x list here, or our x variable if you wish, is s. And so I click on this drop-down menu and I select the s that I see here. And the reason why I can see S here as an option is because I named the top of the column that way. which highlights why it's so important to name your columns. And so here I click S. My Y list is therefore H, and so I click on that drop-down menu and I select H. Okay, I'm happy with all of that, but now before clicking on OK, let me draw your attention towards the fact that on the next line here, the calculator is telling us that it will save the regression line's equation to F1. Now this will become important in a few minutes, so do remember F1, that's referring to the function 1. But we'll get back to that in a minute or two. So I'm happy with all of that, and I can simply click on OK. And we're done. We now have the regression line's equation. Remember, it's in the format mx plus b, and m is equal to 10.2, and b is equal to 39.2. So, going back to what I wrote in gray here, h equals to ms plus b, the m that I wrote here is the 10.2 that we have on the calculator, and the b that we see here is 39.2. So for question 1, we can go ahead and state our answer as h is equal to 10.2 times s plus 39.2. And that's the answer. We now have the equation of the regression line for the heart rate h against the speed s. That being said, I carry on and we now look at question 2. Now in question 2, we're told find the Pearson's product moment correlation coefficient R and describe the correlation. Now, don't let the term Pearson's product moment correlation coefficient worry you. In this context, that's simply the name given to the correlation coefficient R that we have to find. And to find it, well, it appears on our calculator here. Indeed, once we found the regression line's equation with the TI-Nspire CX, it automatically gives us the R value. All I have to do here is scroll down a bit, and I can see it. Well, hopefully you can see it. It's right here. Rounding to 3 significant figures, R would be 0.994. And so for question 2 here, I can state that right away. R is equal to 0.994. And again, I'll go ahead and box that result. There we go. Now we're not done though. Remember in the question we were told to describe the correlation. And put simply, if you get an R value which is greater than 0.9, then you can definitely speak of a very strong correlation. Furthermore, in this case, since R is positive, that tells us that we're dealing with a positive correlation. And so the key words that the examiner will be after here are very strong and positive. And so here I'll simply write a very strong, positive, and we could be more specific and say very strong, positive, linear correlation. Linear correlation. There we go. And I'll even underline very strong and positive. Okay, now that's done, I'll move on to question 3. And in question 3, we're told what heart rate could this runner expect to see if the running speed is 9.3 kilometers per hour? Well, for that, there are 2 approaches really. And I'll show you both of them. And here's what I'll do. I'll quickly write something like this. Option 1, there we go. And for option 1, we'll use the regression line's equation that we've boxed up here. Remember, that was h, which equals to 10.2 times s plus 39.2. And in fact, I'll quickly copy that. That's h, which equals to 10.2 times s plus 39.2. And so going back to the question, if s is equal to 9.3, so if I quickly write that, I'll say for s equals to 9.3, with this line's equation, we'll quickly find that h is equal to 10.2 times 9.3 plus 39.2. And so on the calculator, all we have to do now is calculate all of this. And we can do that on our document here. All we have to do is add a calculator page. And for that, I go ahead and click on the Doc button here. So I click on Doc, and I select the 4th option, Insert, and the 3rd option, Calculator. So I click on that. It's now added a 2nd page to my document. So my first page is the spreadsheet, and my 2nd page is this calculator. And I can go ahead and type all of that. That's 10.2 times 9.3 plus 39.2. I'll double check all of that. That's 10.2 times 9.3 plus 39.2. Okay, that's all looking good to me, so I click on Enter. And we're done. rounding to 3 significant figures, we find that the heart rate we could expect if the speed is 9.3 kilometers per hour is 134 beats per minute. There we go. And I'll go ahead and box that result. Okay, now option 2 on the other hand, let me just quickly write option 2. So again, I'm still answering the same question here, but I just want to show you a different way of doing it with the calculator, which in many ways is a lot more efficient. Remember, on our spreadsheet, when we entered all of our data and we went through the process of actually telling the calculator which column was the X list and which column was the Y list, I pointed out the fact that it was going to save the regression lines equation to the function f1. And here's why that's so useful. If I go back to my calculator and I click on the var button, that's the button directly above number 9 on my keyboard, so I click on var, you can see at the very top here it says f1. And that f1, in fact it's f1 of x, is the function we see here. But it's that function without any rounding on the m or the b that we see here. In other words, we'll have the exact values. So if I click on f1, like so, and I need to evaluate that function when s equals to 9.3, all I have to do is enter 9.3. I exit the parentheses and I click on enter. And we're done. I get 134.06 again. And so on my exam paper, I could just state with GDC, which stands for Graphical Display Calculator, f1 of 9.3 is equal to 134 BPM, and we've rounded to 3 significant figures again. There we go. Okay, now all of that's definitely worth knowing. Remember, when you get the regression lines equation on the TI-Nspire, the function is stored. And so to reach that function, or to get to it, all you have to do is add a calculator page as I showed you, and you can call upon that function using the var button. So do keep that in mind. That being said, I move on to the 4th and final question here, in which we're asked, according to this model, what would a runner's heart rate be if he or she is standing still on the treadmill? In parentheses, in other words, the treadmill is turned off. We're then asked, is this answer reliable? And last but not least, we have to justify our answer. Well, let's see. I'll answer that question at the top here, question 4. And put simply, if the runner is standing still on the treadmill, his or her speed is 0. So we can just go ahead and state that s equals to 0. And if s equals to 0, then according to the regression lines equation that we obtained here, the heart rate we'd get can be found by replacing the s we have here by 0. And so let's see, if I actually write that out, that would be h equals to 10.2 times 0 plus 39.2. But now 10.2 times 0 is just 0, so this equals to 0 plus 39.2, which leads to the heart rate equals to 39.2 beats per minute. And so that's the heart rate we get from our model. But is this result reliable? Well, first of all, in case you don't know, a heart rate of 39.2 beats per minute at rest, or standing still, is very low. Indeed, to the best of my knowledge, this type of heart rate at rest is likely to be reached by highly performant athletes. But whether the runner is here or not, the fact is this result is not reliable due to the fact that when we use this regression lines equation for an s value of 0, we are extrapolating. And extrapolating is not reliable. And here's what I mean. The slowest speed that can be seen in our data here is 6, and the fastest speed that was recorded was 10. And what that tells us is that our regression lines equation is reliable. In other words, it can be used to predict values of h, provided we feed it values of s between 6 and 10. And so in fact, next to this equation here, we could say that that's a good model provided s lies between 6 and 10. Indeed, for speeds between 6 and 10 kilometers per hour, we'd be interpolating. On the other hand, if we start feeding this equation values of s that fall outside of this interval, then we'd be extrapolating. And let me say it again, extrapolating is not reliable. So to answer this question properly here, we would state that this value is not reliable, And we could say something along the lines of since we'd be extrapolating. There we go. And I'll underline that important word there. And if ever you felt that this isn't enough justification for this answer, you could quickly make a sketch, something looking like this. There we go. We'd have a quick XY grid, although it wouldn't be X and Y. It would be S and H here. And the regression line would look something like this. There we go. It goes upwards as we go from left to right. Remember, I know it goes upwards because the correlation coefficient here is positive, and the gradient here is 10.2. And I also know where it crosses the y-axis, or I should say the h-axis. Indeed, that would be at this value here, 39.2. So I could label that really quickly. That value there is 39.2. And so the data that we have that was collected here starts at a value of S of 6. So I can represent that there, and I'll say 10 is right there. And so we have values of data between 6 and 10. And so put simply, the model we have is fine for values of S between 6 and 10. So here we'd be interpolating. And on either side of that, so if we go to the left of 6 or to the right of 10, we'd be extrapolating. So the model, or the regression line's equation, would be unreliable. So extrapolating. There we go. Now, truth be told, if you were to write all of this, I'm sure that's more than enough justification. But if nothing else, hopefully this illustration helped your understanding of what these two terms mean. And there we go. We've now answered this exam question involving the equation of a regression line using our TI-Nspire CX. There we go, everyone. I really hope that helped. And if it did, please hit like on this video, drop a comment down below, and even subscribe to this channel to help get this video to as many students as possible. All that being said and done, that's it for this tutorial.